Excuse me if I keep running off to grab some water. I think I've done too much talking already. As I'm going to do a talk that I gave at Load Days a couple of days ago, so it's pretty brand new material. Unless you've been following me on Twitter, you've probably not seen it. If you've seen it already, sorry. So I'm going to talk about service discovery and configuration management. Hopefully you've got an idea about configuration management after being here all day. Don't worry if you've not heard the sort of terms service discovery, I'll do a bit of an intro there. And the cryptic subtitle will become clear later. You already know who I am because I've been here before. You already know who Puppet Labs are, hopefully by this point. So, this talk I'm going to run through a sort of description of, a sort of quick introduction really to service discovery. I'm going to talk about why it's useful to have, I think, 2 speeds of configuration, and hopefully by the end of it that'll make some sense. I'm going to show an example of using a specific service discovery tool called Console alongside Puppet to sort of hopefully move from the sort of theory to practice, things you can do today. And at the end I've got some sort of rambling thoughts about, I guess, how some of this might fit into sort of traditional change control processes, bits about sort of trust and automation, bits about sort of autonomous systems. So hopefully that's going to be interesting, and we'll finish on time. So, what is service discovery? Like most things, let's start with Google and ask Google what service discovery is. Because for once actually this worked quite well and I ended up with a good quote and I didn't have to write something complicated. So thanks to Jason Wilder for this and to Google. Service discovery is a key component of most distributed systems and service-oriented architectures. I think that's a good statement. It doesn't tell you what it is, but it does tell you it's important. And I think it is important, but what is it? And I quite like this from the same quote. It's basically sort of like, not necessarily about what it is, but what's the problem you're trying to solve? And it is this simple problem of how do clients determine the IP and port for a service that exists on multiple hosts? Now, you can solve that in lots of different ways, and that's the sort of subset of some of the service discovery tools. But bear in mind how you do that now, how you link together multiple machines. So the good news here is there's a whole bunch of sort of theory and experience, often from sort of some of the larger internet sort of companies. And there's already a number of good open source products at different levels of sort of maturity and with different feature sets, but all of them are sort of interesting. I'll show an example using Console, but I'll touch on some of the features of some of the other tools. It's not really about any of them, they're all quite good in different ways. And they're already all in use as well. So actually, I'll go back to my quick show of hands. It's the end of the day. Who's already using like one of those tools? Yeah, so there's sort of a handful of hands. My guess is in a year's time, or that will be a much greater number. And after that, it will get to the point where we're all managing sort of systems using service discovery tools at some point. At least if you're doing things at reasonable scale with far too few sysadmins. So Hadoop is, Zookeeper is extracted from the Hadoop project, so that's sort of cheating. But Zookeeper's been around a while and is pretty solid in lots of use elsewhere. Socket Plane, which is built by Docker, used Console under the hood. Cloud Foundry, actually the new Cloud Foundry uses Console and etcd. Koros, again, that's sort of cheating as they wrote etcd. Kubernetes uses etcd as well. And so these things are starting to be used in higher level distributed systems that are being shipped to users. There's a lot of use, I think, with all of them, like inside companies, but we're starting to see the next set of software coming out with them under the hood. And simply put, they sort of provide, I guess, well, they all have different features and some different characteristics. And these are from the etcd sort of docs, but I think they're quite a good general starting point. They all provide a simple interface to read and write values over HTTP. So it's a distributed database. It's not centralized, it's going to distribute across a bunch of things, and it's going to give you a simple interface to manage key value pairs. So far, so not that interesting, but it's, don't mention key value pairs. But the key sort of, like one of the things that sort of means that it's worth having another system to do this, because you might be thinking, I already have a key value store, is this idea of watching for when things change and reacting to those changes. So it's for me, it's the sort of cross-section between having this available everywhere. It's not the database is over there. It's literally, it feels like it's local all the time. Combined with a very natural way of sort of saying, when something changes, and not just anything, when something specific changes, do something about it. And for those that are sort of like going back to that problem of how do hosts discover other hosts, and how do they know what port or protocol or whatever to map to, you start thinking, well, how could I solve it if I had this, and would that be better than what I do now? For those that are really interested in sort of some of the reasons why these tools are separate from your maybe sort of relational database, or even your sort of NoSQL, sort of Redis, Mongo, whatever, the Jepsen stuff is always worth reading, and there is one specifically around ECD, but there's Jepsen tests for Consul as well, and for Zookeeper. If you've not read that series at all, you should do anyway. It's scary and good, and scarily good. So, why are we seeing people use these now? Why do I say that I think in a year's time there'll be more people using them rather than less? And some of it simply comes down to a desire to move faster. Nearly no one is in a position saying wow, we can just move so fast that we could just set an alarm. We could if you're not able to move faster, and that's not necessarily you move fast all the time, it's the ability to do so when you need to do so, you'll probably get beat by someone else who can. And that sort of throws up lots of new sort of infrastructure patterns. How can we move a lot faster? And as well as that desire to move faster, I'd argue that provisioning times are decreasing rapidly. And that's about virtualization, that is about increasingly containers, that's about sort of good, solid public cloud environments. It's about all these things, and how quickly I can get a computer, or 10 computers, or 100, or 100,000 computers, I think it's fair to say has reduced drastically. And obviously it's not a real graph, but it's definitely going down and to the right. Something that's going up and to the right, as graphs should do, that's a good graph, is definitely, again, the number of applications, and I think the number of instances of those applications that we're managing. I don't think there's that many people I talk to who go, yeah, I manage way fewer things than I did before, either in terms of just the variety or just the number of them. And I sort of joked earlier, and so the number of systems administrators probably are going to stay about the same, at least in terms of the order of magnitude. Sorry, you're going to have to do more work. The sort of good news is that technology is moving towards helping with that, or at least trying to do. I think lots of tools are moving much more towards a sort of cluster-centric, entire system-centric view, rather than individual hosts. Because ultimately, in lots of cases, individual hosts are just too small a thing to reason about anymore. It wasn't the case 10 years ago. It wasn't the case for lots of people 5 years ago. It's not the case for some people today. But if you're managing hundreds, if you're managing thousands, if you're managing tens of thousands, if you're managing many more servers than that, you can't reason about the individual server. You just simply don't have time or budget for all the people that would require. And the sort of that trade-off of many things and few people just means that hard coding everything doesn't scale. So you might be saying, well, how I tell my application servers about the database server is, well, I just write that in a file. I just hard code that up front. I know what it's going to be. And that does work. That gets you so far. But past a certain point, it's going to be changing, and you're going to be wanting to be changing that property. How often? At what point does it become like, whoa, like hard coding this has got crazy? Is it a day? Is it a week? Is it an hour? Is it 10 minutes? I think if you're doing things at a certain level of scale, you're adding things in and out of load balancers so often that the idea that you would hard code the list of like things to proxy to, you just go like, no, like hands up, we can't do that anymore. We need something else to help us. And then, as I said, there are technologies emerging that are both allowing for this, allowing us to take advantage of going faster, but also helping with managing the sort of the resulting change in workflow. So a few people have mentioned Docker. I think I mentioned Docker before. It's actually a surprisingly, for the most part, quite a low-level primitive in all this. So whether that's it's about the containers. There's the interesting idea of sort of Docker as a platform with sort of Swarm, Machine, and Compose at a higher level. But actually, in lots of cases, Docker's fairly low level. Some of the things that I think aren't really low level, at least viewed, so yeah, are things like Mesos, which is very much sort of an abstraction for your entire data center. Not only are you not treating your individual servers as individual things anymore, you're just acting at the level of the data center. And Kubernetes and sort of tools like that, and to a degree Koros as well, are sort of playing in this space. They're bringing new tools to how we can manage infrastructure at scale. This isn't really a talk about those tools. If you've not come across them, I would have a look. I think they probably paint a picture of how systems administration will look like in the future, at least for the majority. So, if that's sort of the, bunch of sort of conceptual stuff around sort of, there's a problem, there's a growing problem. Service discovery, maybe that's something that can help. What do I mean when I talk about sort of two speeds of configuration? So, this is where I think there's this interesting, how you can use these new tools to solve those problems in the context of config management. So I think it's fair to say configuration management tools of various different stripes tend to focus on upfront modeling. They tend to be about managing configuration we know and we want to control over time. It's things like, it's a version of a package. Well, I know that and I want to know when it changes and I want to be the one to change it. It might be user permissions. Again, that's not something that's sort of as free floating. It might be security settings or other system constraints that you want to have, like, you want to be the one to set them up. You want to be the one that changes them, and you want to know when they change. And tools like Puppet provide a really good way of solving that problem. I think like we've got a good way of doing it, and the tooling is just getting better and better. The service discovery tools, sort of, though, handle emergent configuration, which is a property of the system. It's so, again, examples like sort of load balancers and backend, proxy backends is sort of, if you've got a load balancer, it's proxying to a number of hosts. But the rate of change of those hosts, both adding new ones or taking them away, might be such that actually, from a modeling point of view, you don't want to do that on a per host basis. You want to say, well, yes, there's a proxy and it's proxying to all of the servers of this type. That's your model. And you want to be able to describe that model and allow for new ones to come and go without you having to change your model. And maybe it's around sort of network routing between sort of like new things coming up. Where if a new application server comes up, it needs to be able to route to the database, otherwise it's not going to work. But again, if that's happening so often, you can't rely on making manual changes up front or hard coding something or another team to do that for you. The system has to be able to adapt itself. But I think the networking stuff is actually quite a good example because it's not clear cut. Actually, some of that networking stuff you probably do want to hard code up front. You do want to have a strong model around. And some of it is emergent. And I think there are two speeds. There are things that are very much model driven and other things that are emergent. And they overlap. And I think if you looked at all of the configuration that goes into your servers, you could probably apply this sort of idea and sort of say, like, well, yeah, you know what, that is, like, that's very much like rarely changing, I need to be very certain about those things changing. And this is actually a property of the system, however you manage that today. So if you buy that premise, if you're convinced already by the sort of an idea, like how do we mix the tools? How do we take the config management tools that we're using, and how do we mix them with sort of service discovery tools? I mentioned I'll use console for this example. I could have chosen etcd, I could have chosen Zookeeper. There are other tools as well. Console though has a very nice user interface. It has a nice getting started story, and it's probably a good sort of starting point, I think. We'll also use Puppet. Success. Right conference. So first and I'll show an actual working example of this in a moment as well. But first let's install console everywhere. So basically console is a daemon process, you run it on all your hosts. The nice thing is someone's already done all the work. Thanks Kyle. You can pretty much just include console, that's it. So one of the things that I find interesting about Puppet is once you've got set up, you've got a Puppet environment set up, like trying out or adopting new technologies is often as much as that. So if you want to try out Docker and you want to put it on a bunch of your hosts, include Docker. If you want to try out console, include console. I think that's incredibly powerful once you've done the investment. So yeah, I said the module is on GitHub. It's available on the Forge. Shout out to Kyle again. I think some of his colleagues in. So we can configure those. So we've got console there, it's running. But we'll probably want to provide some configuration. Again, we can do this via Hiera. You could do it by properties if you wanted. And we're really just binding it to addresses. Obviously, I'm being naughty here and being promiscuous, but you could be more specific. And how console and to an extent all these tools work is that there's normally a subset of the daemons that are sort of in charge. They're part of the quorum group that will decide whether whether the data is correct or not. So when you're querying, there's a high level of consistency based on the fact that there's Raft or other sort of distributed protocols going on under the hood. So we can tell some of them here and this one's a server and it needs to bootstrap, so there needs to be something to start things off. So, assuming you're believe me, I've now got console installed everywhere, and I've got some console masters, and console wants to, you need all your console daemons to talk to each other. They do this via a gossip protocol rather than directly, so it's not as scary on the network bandwidth as you might expect. And how I've been doing that is just a simple define pipe. So in this case, first is just a host name, and I'm just running the command console join host name. But I'm only doing that if I'm not the first one, bit of a hack. So at this point, not only have I got console installed everywhere, I've got console all talking to each other. So I've now got a distributed system across all my infrastructure. And what we can start doing is populating the service registry. So this is sort of a high-level primitive that console provides on top of the key value pair store. So we can tell console about our services. And to start with, this will be sort of yay, we've told console about our services, and the payoff will come a few slides down the road. So again, super simple. There's a nice defined type. We can say console service. The service has a name and it has a port. We can also provide health check details here. I've not done just to keep that example simple. But all we're doing here is basically, we could run this on all of our machines to tell console about Puppet. So now, if you want to ask console all of your Puppet nodes and what ports they're running on, we can do. And we'll do something a bit more interesting in a moment. And one of the nice things I mentioned about console is you get this sort of dashboard for free. You get this, not only do you get a tool which you can query from any of your nodes for the services, but you get a nice service dashboard. So we can dig down into the different nodes that have registered, we can dig down into the services that are available. And remember, we can query this as well. So there's all sorts of tools and you could imagine building on top of this. Monitoring is just one sort of great example, I think, but there's lots of others. So one of the nice things about Puppet is that it's a programming language. We can build our own high-level primitives. So let's do this. I should have changed this because it was confusing before, but basically, I've defined a thing called application. That should not have that should be something more specific rather than such a generic word. But it's going to be one of your applications. Maybe it's something that manages calendars, or maybe it's something to do with a content management system. And I'm being fancy and I'm running like for each of these applications, it's a Docker container, but that could be install a package, it could be start a WAR file up, it could be anything, or it could be dropping some PHP code into Apache. Any and all of those things amount to like, it's the essence of your application. And actually, most of the top bit is probably something similar to the code you already have. You've got a defined type, and you've got something that defines your application. And all we're doing is actually describing at the bottom, we're registering this with console. In this case, we're giving it a specific name and putting it into a port. The reason for the sort of service name property is just uniqueness. Because we can run multiple copies of this application on a single host. So we could run these on multiple hosts, we could run them on single hosts, we could run them in a combination. So all we're doing here is running 4 versions of that on different ports. And this will fire everything up in Docker and it will register it all with console automatically. I said the Docker stuff is just an implementation detail here. So we've now put a load of information into console and we've got a dashboard, which is nice and interesting. Was it worth the price we paid? I'm not sure yet. This is where it starts getting interesting though. We can start using the information we've put into console from Puppet. So one of the ways of doing this is literally just, there is a console Hira backend. And so we can include that in our backend, we can include the configuration in our Hira config, and suddenly we're able to query from within our Puppet code services and information from Hira. So it's probably a little bit small, but at the bottom you've got sort of different paths we're looking for, and we're querying on the catalog service. So basically any of the services with those names, if we look in Hira, we'll find them. So I'm going to use the Hira function and pull out all of the applications. So our application defined type is automatically starting a bunch of applications, registering them in console, and I can now pull them out elsewhere in my Puppet code. And I wrote a console to Nginx function that's very simple bits of Ruby. There's literally just like data spelunking. Some of this you can increasingly do with the feature parser. But all I'm doing here is taking the information from console and converting it into a format that allows me to put it into an Nginx config. So that's the module that's allowing me to do this, which you should have a look at. So at this point we've got this whole, well, we can put information into console and we can get it out and use it for other things. And we can get that information back into Puppet. So the example I was using was sort of, well, configuring Nginx. So actually, whenever we add new applications, and we run Puppet on our machine with Nginx, the Nginx machine, the proxy, the Puppet code will go and ask console, hey, tell me about all these applications that I need to proxy to. Then you can build the Nginx config, and it will be there. But at that point, you've still got, basically, you might bring up your proxy, and the proxy will ask for services, and there won't be any. They might then bring up a few nodes running all these applications, and then you need to go back and run Puppet on the original host in order for it to populate. And if you tear down those machines, you'd have to do that again. And it's all going to work, but the feedback cycle isn't there. But going back to the start where I was talking about console and service discovery tools allowing you to react in real time, to watch for changes. Well, we know what to watch for. So we can trigger Puppet runs based on changes to our application service registry. So again, there's a console watch type, and I've not shown the innards of the run Puppet script, but you can sort of imagine what that's going to do. And the important bits here are where we're going to watch for changes to the application service. So whenever a new service is added, Whenever a new application is added to that list or taken away, this is going to trigger a Puppet run on the relevant machine. So we've now got the entire thing. So I'm going to try and demonstrate this by doing a live demo in front of everyone. Right. Bear with me a moment. So is that big enough? Hopefully. So I've got Puppet all set up on I think 4 machines. I've got console all set up on all those machines using the code. So we've got a bunch of nodes in our console cluster. We've got a bunch of applications already running. And I've got a sort of page which, like this is each one of each. This is pointing at the Nginx proxy, and I should be able to refresh this. But I think Chrome will probably cache it a bit. There you go. You can see it changing. A better example of it changing is I'm going to run just a while loop curling the Nginx point, and all you can see is basically there's sample 1, 2, 3, and 4 running on 2 nodes, and you can see it basically balancing between there's 8 applications. You can believe me there on 2 hosts. One of the hosts is called second, one of the hosts is called third. And each of the applications, you get the idea. So on the other side of things, I'm logged into the machine called third. And I can ask the machine sort of, hey, what's the state of the console cluster? So you can see it's got first, third, and second all in there. They're alive. There's 2 clients and a server. And so it's all connected together as I've been describing. And I'm going to leave that cluster. So if I were to run console members now, it would just say, well, I'm just a cluster of 1. Console's still there, but I'm not connected to anything. And behind the scenes, console has gone, oh, well, right, all those applications have disappeared. So if I was to refresh this, you'd see that, well, there's less nodes, there's less applications, there's 4 of them now. And, oops. If you look at the proxy, is now just going to 1, 2, 3, 4 on second. Third's disappeared automatically. Behind the scenes, Puppet ran on the proxy because I shut down console. So, in theory, if I join console, so again, I can do console members, I'm back in the cluster. So in theory, I've updated the service registry, which should trigger a Puppet run behind the scenes, and if I keep talking slowly, we should see third start appearing. Yep. And so the feedback cycle there is really fast. We're able to model things in Puppet, we're able to take advantage of, well, we're able to model things in Puppet, we're able to export a bunch of that pertinent information into our service registry, and we're able to bring that information back into Puppet and run Puppet whenever anything in our service registry changes. That's pretty powerful, I think. Oh, hopefully people agree. So, exactly the same sorts of things are possible with Zookeeper, with etcd. I think the current state of the modules support in Puppet, the console stuff's a little bit further forward. I wrote an IRA backend that the console one is based on for etcd, so you can do the same sorts of things there. And Carl Anderson again wrote a module for installing etcd, although you normally, I think, need confd as well to do some of the watching or other tools as well. So what are some of the advantages of doing this? It's not just play with new tech, and we talked about some of the problems. But what I'm sort of liking about it is that sort of, well, changes can happen really quickly, but without losing the ability to address the sort of, like, we're not throwing one thing away for another thing. We're not sort of saying, well, we want both, but we have to choose one of them. We're able to get the best of both worlds. One of the other side effects of this is that if you're in a situation where you're defining lots of things to watch, and you're defining lots of things that could happen when something you're watching changes, there's complexity on both ends of that. And ultimately, you need a way of tracking that complexity, managing that complexity, and that can get quite complicated. One of the advantages of like using Puppet as the thing you run is there's a single output. Like when something changes, you run Puppet. And the nice thing there is that you've massively cut down the complexity. You've still got the complexity on the side of the watchers, but you can manage that by modeling it, by describing things in defined types, by coming up with something that makes sense in your context, and the output is always just run Puppet. And all changes to configuration, whether they're upfront and they hardly ever change, or whether they're runtime their changes, they're all tracked in one place. They're all available as a Puppet report. So if I remembered to go have a look at the console, there would have been a Puppet run for each of those updates to the proxy. It wasn't triggered by the daemon running every period of time, every half an hour. It was triggered by the watcher. And so we've got reports of everything that happens. We don't have to sort of trade one for the other again. And we're defining all our watches in code. Again, you could just drop some files onto disk, but we've sort of got past that. We've got to a point where basically we know the advantages of describing things in code. We shouldn't, again, throw those things away. And we're removing duplication if you're using one tool to sort of create things and another tool to continue that evolution. You end up probably duplicating something, because you want it to exist to start with before anything else happens. And in the worst case, it's sort of, you could have two tools fighting for the same contents of a file. Here we're only making changes via one route, but we're also getting information only from one source in terms of the service discovery tools. I didn't show as part of the example, but then I thought when I was writing the spec, actually there are other uses as well, and I'm a big fan of sort of multi-use tools. And remember we've got this agent running everywhere that we can ask questions, that distributes information automatically across our cluster really cleverly. If you're in a position where you're managing lots of identical files on disk across loads of hosts, why not actually push those into the distributed key value store? So I actually wrote a module to do just that a while back. So here it's just key value config sort of type, and here all we're doing is putting the value bar at the place foo, and we can get that back out as exactly the same way as we got things out for the service discovery aspect. So if you wanted, you could pull those into files, or you could just have your application ask console or etcd or Zookeeper for that information rather than having to rely on things on disk. I think that'll sort of be a growing pattern. And the nice thing with sort of some of the features like this, and there's some talk of sort of standardizing some of the interfaces as well, which will make implementations easier, is that the type I wrote basically just allows you to toggle between different providers. So you've got that, we're back to where Puppet's been, so let's just talk about packages, let's just talk about files, not let's talk about the implementation details of those things. And that's all available on the Forge and on GitHub as well. So, I mentioned sort of briefly at the start around sort of, I'd talk a little bit about how this fits into sort of change control processes, because I think the idea behind sort of a lot of sort of ITSM type sort of change control processes is weighted towards modeling up front. It is weighted towards having that strong model. And I think if you throw away the model, you throw away the processes, you can end up in trouble. On the other hand, if you don't take advantages of autonomous systems, of systems that are going to be better and faster at doing a job than you can be, you'll lose as well. And I think combining the tools together like this, actually, you can get the best of both worlds. You can have a strong model, you can have a strong change control process around specific aspects, and you can have this more flexible model and the ability to react to changes, all in something that can be fairly straightforwardly audited and rolled out and changed. So you're changing the model, not the implementation. Hopefully that makes some sense. I think that comes onto the need to sort of trust automation. And I guess the ability for us to learn to trust automation. It's one thing to have to move from typing commands and going like, well, I type a command and something happens and the feedback is there, to running a script against one server, and that's sort of like, that's still like, wow, that's magic. Like, that server's over there and I'm not logged in and it changed over there. And then suddenly you do that over like parallel SSH or something, and you change 10 servers at once, and that's like really magic. And then you sort of like start using like declarative tools like Puppet. And again, you're becoming further and further away from that direct feedback. And I think you're slowly building trust in the tools to do the job that you were previously doing. And I think with the need to react much quicker in real time is sort of going to push that even further. How do you learn? Does your team and your organization learn to trust automation? That's a really interesting topic. And I started with that sort of like there's two speeds of configuration. I do think that some things need to be able to be changed really quickly. I think some things don't. It's not one or the other. You need both. And hopefully I've convinced you of that. So, thanks for listening. I'm aware it's the last talk of the day, but if you do have any questions about any of this, feel free to ask them. And hopefully that was interesting.